In this video, we're looking at our half-angle identities. We use these identities similar to the double angle identities we saw in our previous video. The formulas are very different, but the idea of starting with an angle where twice that angle is something that's on the unit circle, but what we have, that half of it, is not. For our half-angle identities, we have a half-angle identity for cosine. We have one for sine, and then we have three versions for tangent. So cosine of a divided by 2 is equal to plus or minus the square root of 1 plus cosine a over 2. Sine of a divided by 2 equals plus or minus the square root of 1 minus cosine a over 2. Tangent of a over 2 is plus or minus the square root of 1 minus cosine a divided by 1 plus cosine a. Or tangent of a over 2 equals sine of a over 1 plus cosine of a. Or tangent of a over 2 is equal to 1 minus cosine a divided by sine of a. The plus or minus is going to be dependent based on where our angle lies. So that sign will be dependent and figured out as we work through the problems. Find the exact value for cosine of pi over 8 using the half-angle identity for cosine. So pi over 8 is our angle, but we don't have pi over 8 on our unit circle. So we're going to let a over 2 represent that pi over 8. So if we were to multiply both sides by 2, this tells me that a is equal to 2 pi over 8 or pi over 4, which is an angle that we have on our unit circle. So cosine of pi over 8 is equal to plus or minus the square root of 1 plus cosine pi over 4 divided by 2. Now, when we think about the value pi over 8, we know where pi over 8 lies. If we think about our unit circle, the positive x-axis is 0 radians, positive y-axis is pi over 2. So pi over 8 is in that first quadrant, which means that cosine is going to be, or cosine of pi over 8 is going to be positive. Pi over 8, again, somewhere in that first quadrant. We know cosine of pi over 4 is the square root of 2 over 2 divided by 2. And now we want to clean up this complex fraction underneath the radical. We're going to do so by multiplying by 2 over 2 underneath the radical. This gives me the square root of, or the square root of 2 plus square root of 2 divided by 4. Since 4 is a perfect square, we can simplify that. This is the square root of 2 plus the square root of 2 divided by 2. Be really careful with your syntax here. We have that square root underneath the square root, and we don't have the skill set to simplify that any further. So we're just going to leave it like that. But we do want to make sure that we simplify anywhere within the radical that we can, such as that 4 in the denominator. Find the exact value of sine of 195 degrees. If we think about 195 degrees, if we were to double that, we would get 390 degrees. So let's assume that a over 2 is 195 degrees, which means that a is 390 degrees. If we think about 390 degrees and we try to determine a coterminal angle for that, if we subtract 360 degrees from this, we're going to get 30 degrees. So 390 degrees and 30 degrees are coterminal angles. So setting up our formula, sine of 195 degrees, or a over 2, is equal to plus or minus the square root of 1 minus cosine of 30 degrees. And I'm using that coterminal angle instead of the 390 because the signs will be the same. If they're coterminal, there's no change in the signs. They have the exact same function values. If we were looking at a reference angle, then we would want to be a little bit more cautious with signs. Over 2. If we think about 195 degrees, 195 degrees is going to be in Q3. And in quadrant 3, sine is negative. So we're going to use that negative out front. So sine of 195 degrees is equal to negative square root 1 minus cosine of 30 degrees. Let's think about cosine of 30 degrees. So setting up that triangle, again, we're seeing that flatter triangle. So the x is longer than the y. So square root of 3 over 2, 1/2 is the ordered pair at 30 degrees. Cosine is the x coordinate, so 1 minus the square root of 3 over 2 divided by 2. And again, to simplify this complex fraction, we're going to multiply by 2 over 2 under the radical. So this is 2 minus the square root of 3 in the numerator when I distribute that 2 over 4. Factoring out the 2 from the square root of 4. So square root of 4 becomes that 2. And just making it a fraction of 1/2 times the square root of 2 minus the square root of 3. You could also write this as that negative square root of 2 minus the square root of 3 over 2 without making that a coefficient out front. Both forms are the same. Given cosine of theta is 2/3 and theta is between 3 pi over 2 and 2 pi, find sine of theta over 2, cosine of theta over 2, tangent of theta over 2. So we're given that cosine is positive because cosine of theta is 2/3, which means theta is in quadrant 1 or quadrant 4 based on that piece of information. Then it also tells us that theta is between 3 pi over 2 and 2 pi, which is quadrant 4. So we'll set up our picture because we are given the value of cosine theta is 2/3. So the adjacent side is 2, the hypotenuse is 3. Now we're going to probably need that other side. So let's go ahead and complete this triangle using the Pythagorean theorem. Three squared equals 2 squared plus y squared. 9 equals 4 plus y squared, or y squared is equal to 5. Since we're in the fourth quadrant, y is going to be negative. So y is equal to negative square root of 5. Using our formulas from above, sine of theta over 2. In quadrant 4, remember, our angle is in quadrant 4. Sine is going to be negative, so it's going to be negative square root of 1 minus cosine theta over 2. Excuse me. Theta is in quadrant 4. We need to think about the sign for theta over 2. So before I commit to my sign, which I just realized I made an error, the way that we can determine where theta over 2 lies is by using this piece of information that theta is between 3 pi over 2 and 2 pi. So 3 pi over 2 is less than theta is less than 2 pi. If I were to divide theta by 2, I would just do the same thing to the other two sides. So multiplying by 1/2. And that will give me the range of values for theta over 2. So theta over 2 is going to be less than 3 pi over 4. Or sorry, greater than 3 pi over 4 and less than pi, which is going to be in Q2. So theta over 2 is in quadrant 2, and sine in quadrant 2 is positive. So the sine of theta over 2, the sine of sine theta over 2 is positive. So positive square root of 1 minus cosine theta over 2, or the square root of 1 minus cosine of theta, looking at my triangle, is 2/3 divided by 2. Now, getting a common denominator, we only actually have one denominator here of 3, so we can multiply by 3 over 3. But you could have done 6 if you're thinking about that 2 in the bottom, but the LCD is actually 3 because there really is only one fraction, that 2/3. Start in the next line. This simplifies to the square root of 3 minus 2 over 6, or the square root of 1 over 6. The square root of 1 over 6 is 1 over the square root of 6, which then we will rationalize by multiplying by the square root of 6 over the square root of 6, giving us the square root of 6 over 6 as our final answer for sine of theta over 2. All right, let's look at cosine of theta over 2. Since theta over 2 we discovered was in quadrant 2, cosine in quadrant 2 is negative. So this is going to be negative square root of 1 plus cosine theta over 2. My work's getting a little crowded. Sorry for my added division lines, or lines to divide out the work. 1 plus cosine of theta is 2/3 over 2. We're going to use that same special one of 3 over 3 to clear out that complex fraction in the radical. Negative square root of 3 plus 2 over 6 equals negative square root of 5 over the square root of 6. To rationalize, multiply by the square root of 6 over the square root of 6. Which is negative square root of 30 over 6. And then last, we'll find tangent of theta over 2. We saw this in a previous video. I can use my half angle formula for tangent. There's 3 options here. Or I can use what I know from sine of theta over 2 and cosine of theta over 2 and use that quotient identity. So tangent of theta over 2 is sine of theta over 2 divided by cosine of theta over 2. And we have those two values. So this was square root of 6 over 6 divided by negative square root of 30 over 6. Those denominators of 6 simplify to 1. So this is the square root of 6 over the negative square root of 30. And to rationalize, we'll multiply by the square root of 30 over itself. Or we could simplify this. Let's look at simplifying this. Since we've got a radical divided by another radical and they both have the same index, we can write these back as one radical. So this is negative square root of 6 over 30 or negative 1 times the square root of 1 over 5, simplifying that 6 over 30. We can simplify this to negative 1 over the square root of 5, just simplifying the square root of 1 in the numerator, making sure we keep that factor of negative 1, and multiplying by the square root of 5 over the square root of 5. We get negative square root of 5 over 5 for tangent of theta over 2. This approach, if I look back at my second step where I had square root of 6 divided by negative square root of 30, we could multiply by the square root of 30 over the square root of 30. But what's going to happen is in the numerator, we're going to have whatever 6 times 30, 180. And then we're going to have to simplify that square root, which might be a little bit more work than we wanted to get into. So it really just depends, but it could be done at that point as well. We could have rationalized there. We just would have had to simplify a radical. Simplify 1 minus cosine 5 theta over sine 5 theta. Using those half angle formulas, I can identify that A is going to be 5 theta. So this is 1 minus cosine A over sine of A, which is our half angle formula for tangent. So this is tangent of A over 2 or tangent of 5 theta over 2, which we're going to leave it like this, not that 5 over 2 can't simplify any further. Plus or minus the square root of 1 plus cosine 12x over 2. We're going to let A be 12x, so this is plus or minus the square root of 1 plus cosine A over 2, which is our half angle formula for cosine. So this is cosine of A over 2 or cosine of 12x over 2, which we can simplify this. So this is cosine of 6x. Now, we're also going to introduce these two other sets of identities, product to sum identities and sum to product identities. You're not going to be assessed on them in my class, but they are used in applications in like a Calc 2 class. So you might see them eventually. So this will at least give you some familiarity with them. But I would expect when you're using them in your upper level Calc classes that you will revisit these. So we're just going to go through two quick examples just to illustrate how we can use these different identities. So again, we have product to sum, which is if we look, the formulas for cosine of A times cosine of B, or sine of A times sine of B, sine of A cosine of B, cosine of A sine of B. So just kind of giving us some different combinations of multiplying two trig functions. And we have our corresponding formulas here. So we want to write 2 sine 58 degrees cosine of 102 degrees as the sum or difference of two functions. So we have the product of two functions, sine of 58, cosine of 102. So we're going to let 58 be angle A, cosine B, or 102 be B. So this is really 2 times sine of angle A times cosine of angle B. The sine A cosine B can be expanded using these product to sum identities. So we've got 2 times, and I'm going to make sure I have some parentheses here. Sine A cosine B is equal to 1/2 times sine of a plus b, or 58 plus 102, plus sine of a minus b. So sine of 58 minus 102. Now I'm going to start simplifying from the inside and working my way out. I think that's a little bit easier to see. This is going to be sine of 160 degrees plus sine of negative 44 degrees. And even here, I think it's easier to see that that factor out front of 2 multiplied by that inside factor of 1/2, those are going to multiply to give me 1. So then we're just left with sine of 160 degrees. And then sine of negative 44 degrees, because sine is an odd function, this is the same as negative sine of positive 44 degrees. Similarly, we have formulas that go from sum to a product. So if we have sine of one angle plus sine of another angle, we can write that as the product of two trig functions. Write cosine 3 theta plus cosine 7 theta as the product of two angles. So we're going to let 3 theta be our A, 7 theta be our B. And this is really just cosine of angle A plus cosine of angle B, which, using our sum to product formulas, this is 2 times cosine of A plus B over 2 times cosine of A minus B over 2. Substituting in our values for A and B, cosine 3 theta plus cosine of 7 theta is equal to 2 times cosine of 3 theta plus 7 theta divided by 2. Times cosine of 3 theta minus 7 theta divided by 2. Simplifying those arguments, 3 theta plus 7 theta is 10 theta, divided by 2 would be 5 theta. The second argument, 3 theta minus 7 theta is negative 4 theta, divided by 2 is negative 2 theta. And because cosine is an even function, cosine of negative 2 theta is equal to cosine of 2 theta.